Good morning everyone. In this video, we are going to discuss about flame photometry, one of the important analytical techniques. So, we are now going to see about some basic fundamentals of flame photometry with the instrumentation diagram. So, the principle of flame photometry is based on the measurement of emitted light intensity when a metal is introduced into the flame. The wavelength of color gives information about the element, and the color of those flame will give the information about the amount of element present in the sample. It means color gives what element it presents, and also how much quantity. That's why it says the amount of element present in the particular given sample solution. Okay, it can be detected through detector and recorder, and it can be elaborated as follows. The solvent is first aspirated to obtain the fine solid particles. It means from the solvent we can get first solid particles. So these molecules in the solid particles are moved towards the flame to produce gaseous atoms and ions. Okay, it produces gaseous state of atoms and ions. So these ions that absorbs the energy from the flame, and it will be excited to the higher levels from the ground. But as these ions are unstable, if it is unstable, they return back to the ground state again. While returning, they emit characterization take radiation. Some radiation it has emit to the state when it is returning to the ground state. So the intensity of emitted light when it is returning is directly proportional to the concentration of the element present in that. So based on the color we can detect some basic uh, element present in the solution. That's why this slide shows that sodium around 589 nanometer, it's yellow color; potassium 7766 violet; barium lime green around 554 nanometer; calcium 622 nanometer orange; lithium 670 nanometer red. So this is the principle of flame photometer. A liquid sample, then formation of droplets, and it is converted into residue, and then the neutral atoms formation, and excited atoms by energy, that is thermal energy. Emission of radiation of specific wavelength, the intensity of emitted radiation is measured finally. That's why it shows the picture, simply shows the picture ground state, and that is excited state, and also it is absorbed energy when it absorbs the energy. After that emitted, which finally intensity of emitted radiation is getting measured. So advantages, disadvantages, and application. Advantages: method is very simple and economical, and it is very quick, convenient, selective and sensitive, and it is qualitative and quantitative, and very low concentrations are enough to use this. Estimates the elements which are rarely analyzed, and also it is shows that a very limited amount can be needed. And what are all the disadvantages? Cannot determine the presence of inert gas. That's the main disadvantages of flame photometer, and cannot provide the molecular weight of the metal. So by other techniques we can review the molecular weight, it shows, but flame cannot. Only liquid samples can be used. That also some of the disadvantages. Carbon hydrogen halides cannot determine due to its non-related nature. So these are all some of the disadvantages of flame photometer among the researchers. So applications, where it is applicable: to to estimate sodium, potassium, calcium, etc. Even in serum, urine samples also you can review, and other body fluids also. These are some of the versatile applications of using this flame photometer. Even soil extracts, plant materials also we can review it. Used in to determine of alkali and alkaline earth metals, it is very important. Determination of lead in petroleum samples, that is also important application of using flame. Used in the study of equilibrium constants involving an ion exchange resins, and also calcium and magnesium in cement material. So these are some of the main applications. The application shows a wide variety, especially CSF, urine samples and all, body fluids and all. It is very very important to use this flame photometer for these reasons, especially in bio, and also in vast petroleum, cement, everywhere it is using. So such a versatile technique it has. Even though it is very sensitive, it can be applicable everywhere. For this reason, it is highly appreciable to use this flame photometer. So thank you so much.